video number 2 of Build Your Own Robot. This is the controller section. Specifically in this video is the microcontroller. We're going to go through step by step using my main brain project how to build a controller, and we're going to just start at the beginning and go all the way through the controller, and then we'll get into the motion board and stuff. But right now this is the controller and subsection microcontroller unit. So we have Build Your Own Robot, we have the introduction, and then we had video 1, which was the controller, and then video 2 is now. This is like a sub section of this, so this will be the MCU, and then we'll go on down to the different parts of the controller, and then we'll go on to the DSP and motion and all that stuff. Okay, so at the heart of the controller is the MCU. So it's the microchip, 32-bit, it's the PIC, 32, MX, 500, 600, and 700 series. This is the same family, so any of these will work. It has to be an MX. A 32 means 32-bit. PIC is trademark name. All right. Okay, so the PIC or the 32 means 32-bit. It has various sections that we're going to get into. All right, but first thing, we're going to get to where we're going to discuss the basic parts, the basic things that you need to do just to get it up and running. Do a hello world thing. Usually it's what I do. I turn on an LED or set, a port pin high, and then from there on you can build on that. But you got to get some life into it, and this is what the minimum requirement. Okay, so there's your MCU. Right now we don't care about what's in there. We just want to get it set up to where we can write code and expand from there and study the internals. All right, so the first thing you need, it runs on 3.6 volts, 3.3, whatever. So you need a 3.6 volt power supply. All right, so there's more than a couple power supply. So you have VSS and VSS, VSS, and VSS, and also VDD. Alright, so there's 4 points around the chip that you have to supply power. And there's also 2 analog voltage pins. AVSS, and AVDD. Those have to be tied to power too, or it won't work. Alright, see what we got here. Alright, so this microchip says you gotta have decoupling tabs. It will actually work without them, but it's always good to have a clean signal. Alright, so they're all 0.1 microfarad. Alright. Then there's a special one called the V cap. And it has a cap that goes to VSS. And that is because the MCU internally runs on 1.2 volts. So this cap sets the voltage for it in there, internal. It's an internal thing, but you have to have this thing. It's for the internal voltage regulator, it says. All right, so then you have to have the data sheet. Never try to build something without the data sheet because you're blind. You gotta know what's going on. And the data sheet is the only way you're gonna know what's going on. All right, so then we got the reset pin. Let's pull it over here. All right, and they call it the memory clear. Yeah, active low. So it's just, when that's low, it just resets the processor. And it'll stay reset until it goes high. Alright, so there's various ways that you can reset it. I'm going to use, I use Reset Supervisor. We'll get into that. Or you can just use an RC circuit. But just to get started, you don't really have to do anything with it. It wouldn't hurt to have it pulled high with like a 10K resistor. But it's going to go over here. So we have you don't even have to put a clock into it because it has its own internal clock. It's called the FRC. So the only other thing you need is a way to send the code into it. And then, all right, and then this will also, well, let's just get to it. ICSP connector. In-circuit serial programming. I got it right this time. In-circuit serial programming. Okay, so it's 5 pins. It used to be 6, so a lot of times you will see 6, but it's just a no connect. No connection. So this will be like pin 1, 2, 3, 4, 5, and 6. I pretty much eliminated 6 from my stuff because it's been deprecated. It's just, you don't use it. All right, so pin 1 of the ICSP is the memory clear pin. All right, that's just the direct. They don't want you to have any kind of diode or caps on this thing while you're using it as a programmer. All right. So pin 5 is a special pin called PGED. And then there's pin, oh wait a minute, that's C. EC, and then this one is PGED. They changed the names on the 32-bit processors from the 8-bit processors. I think the 8-bit was PGD, I think, and PGC. And that's where the actual serial data from the programmer goes in and out of the chip. Then we have, let's see, pin 2. Pin 2 is the VDD, and pin 3 is VSS. So VDD is the 3.3 volts, and that's your zero ground potential. All right, and you can use the programmer to power the chip if you desire to. So you could do without this for the first start of the programming, but You're gonna need a power supply later anyway, so you might as well do it. Okay, and then B-cap. Okay, so B-cap, they want you to have a 10. Oops, that's a bad micro. A 10 microfarad capacitor, and they want it to be a 10 ohm. And they want the ESR to be less than or equal to 3 ohms. And it says it has a note, it says aluminum or electrolytic capacitors should not be used. Alright. So that's a requirement by microchip. Because it's for the 1.2 volts, it's important. That's the minimum requirements to get this thing up and running. So then, the next thing to do is you gotta have MPLAB. And the newest version is called MPLABX. It's version 5 point something. Alright, so you can download that free from Microchip at the microchip.com website. And also, one good thing I like about Microchip is they have the Microchip forum. And those guys, if you have any problem, they'll help you out. And I mean, they've helped me out with some problems where I just could not figure it out. And I just was banging my head against the wall. And sometimes it would be easy, and sometimes it was hard, but I just misunderstood what really I needed to do. And that happens a lot. Alright, that's about it. That's the minimum requirement. So you have, in order to do it, so here's your project. Mine's called Main Brain. And it has a little PIC microcontroller in there. Alright. So then you have MPLABX. It runs Windows. I think they have it for Linux and Apple, I think. Don't quote me on that because I'm a Windows user. Alright, so they have MPLABX, and then you have some kind of debugger programmer. And for the 32, you can use ICD debugger. I think, yeah, in-circuit debugger. I think they call it the ICD, and I think you need the 4. But just to program it, you can use the PIC kit 3. The 4 works fine, but they have it in the yellow, a caution, because it's kind of like in beta mode right now. So the PIC kit 3 will work just fine. So you write your code in MPLABX. You send it through the USB. It just plugs into the USB. Send it to the PIC kit 3, and the PIC kit 3 has the wires come out for the ICSP. And that sends it into the microprocessor. Alright? So MPLAB, you can use to, well, alright, MPLABX. You can use the C language. I think they use, it's called the XC32 compiler. And you'll have to download that, it's free. Download that separate because it's like a tool chain, they call it. It has MPLABX for assembly built in, I believe, unlike the 8-bit ones. And I think you can use assembly for sure. And I think it's set up for like C++ or something too, but it's C and assembly is going to be our main diet on this project. Probably mostly C. As much C as we could possibly get away with, put it that way. Alright, so now that we've set up the processor for a minimum requirement, we need to test our hardware to make sure that it works before we go any further. So we need to write some code. So we're going to use the C language. Whoops, I can't spell today. Alright. So every C language has to have a function named main. So and then we do our little brackets. Okay. Now, in order to do so the XC compiler lets you do bit manipulations. They have a header file that allows you to do that. So if you include it, XC xc.h. If you include that, you gotta get our little pound sign here. If you include that, then you can do bit manipulations. So basically, if you have a port or a register, any register that's in the header, instead of port B equals hexadecimal 84, instead of that, we might not want to change the whole port, because you might have other bits of the port controlling other things. You don't want to disturb it. So you can go like this, port B, this is all uppercase, and lowercase bits. And when you punch in the decimal point, it brings up a menu, and it'll ask you which bit you want to change or set, and then you select, like in our case it'll be bit 7, and then equals 1 or 0 or whatever you want. Alright, so you can do that. So in order to set up the port as an input or an output, in our case an output, we have to do the TRISB, the tri-state register. TRISB bits dot, I think it's RB7 actually. Microchip likes to put an R in front of it. RB7. And we want an output, so the output is 0. So that makes port B7 an output, and it doesn't affect any other bit in port B. So then the next step is just to tell the compiler what you want to come out of port B on the pin. So you just go port B bits dot Menu comes up, you select RB7 equals, and we want it to turn on the LED, so we want it to be a 1. And that's our program. Then we have to do a return. We have to have a return for the compiler, even though it's main and it never really returns. It wants you to have one, so we'll return 0 because we don't really. If it did return, it would be bad. So then, erases there. All right, and then our main function almost always has an endless loop, so that it comes down and it either executes your code and then stops and just does endless loop, or it initializes code and then it goes into a loop where it just loops through the whole thing like an operating system, and that's what I use on MainBrain. It loops through and it just scans the screen for a key press and or a screen press, and once it's pressed, then it branches off into another routine. But so we need this while 1, and it's always going to be 1. So it's just going to sit there and it's going to loop endlessly. So in this particular program, it's going to come down, it's going to configure port B, RB7 as an output pin, and port B, RB7, it's going to make it a high, 3.3 volts on 1, turn on the LED on MainBrain. Okay, so then the only thing left, we'll go to the bench and we'll hook up PIC kit 3 and load MPLABX and compile our code and send it to MainBrain and see if it works. And here's MainBrain. It's in the process of being, I'm starting to work on the motion board, so this is going to be the prototype for the motion board. So MainBrain's going to go to work. So here we go. We have a PIC kit 3, all right, and we have an ICSP cable. All right, the red wire is pin 1. The little triangle is pin 1. So you have six wires, even though we only use 5. That's an old legacy thing. So I gotta feed this under MainBrain here. See, right here's MainBrain's ICSP connector. I don't know if you can see in there or not. That's where it is. Alright, and then I got this thing right here. Make sure I got it on the pin right. Alright, then we have USB cable, a mini B. Goes right in here. The PIC kit 4 uses the micro type USB, this one right here. Alright, so now we're connected. There we go. Then we got to apply some power. Okay. There's MainBrain running this software, which we're going to overwrite here. Alright, so here we are. We load up our MPLABX IDE. Version 5.5 should be the latest version. Alright, here we are. Blank slate, ready to create a project. So we go File, New Project, Standalone Project. Next. Alright, then we select our device, 32-bit, PIC 32. The device is a PIC 32 MX795F512L. We pick our tool, which is our PIC kit 3. have to select this compiler. You'll have to download and install the compiler before you create a project. Alright. Okay, now we got to create a project name. We'll just call it test for right now. And I like to use the same project location, and I'll overwrite an existing project that's there. Alright, finish. Alright, here we go. Now we have a project entitled test. So we need to put our main function in there. So you just click the new file, and we want a C file, and I like to do the source because it's blank. I don't like their header. I like to put my own in there. So click next. Make the file name, it's got to be called main.c. Well, it don't have to be called that. The function has to be called that. And finish. Alright, we have our blank file. And then you want to do a comment on the header and just put whatever information you want to put. Supposed to put like the author, date, what it does, different things. Alright, for right now this is it. We want to include the header file for the XC32 compiler. So we do an include xc.h, and then we start our main function, integer main parentheses, get our little containers in there. Alright, and then you want to save it because it'll need to load that in there. I had problems with that before. Alright, so then we want to do our return. We want to return 0. Alright. And while we're here, we'll do our while loop. Get that in there. While 1. Alright. I like spaces. I like a lot of spaces in my code. Alright. And then the next one will be, we have to configure the port pin for input or output, and we want to do output in this case. So we go tris b bits dot, and menu comes up. We want to choose B7, and that equals 0 for output, and then we're gonna write the data to the port pin. So port B bits, menu pops up, we select RB7, and then we want to turn the LED on, so we write a 1, and that's our program. So you can come over here and right click on the project, and then you can build it if you choose. Alright, so it compiled it, it created a hex file to download, and you can also build it and program it to the chip in one button press right here. Just click that. There, it compiled it, connecting to the programmer, connecting to PIC kit 3. It detected the voltage, that's the chip, the revision, it erased it, programming it, and it's done.